Hello, and welcome to this presentation by Amelia, Rector, and Tran. In this video, we will be talking about the Brahmagupta Theorem. The Brahmagupta Theorem is a very simple theorem once you get to know a few basic definitions and theorems in geometry. Most of this video we will be spending going over the basics in order to prove the Brahmagupta Theorem. The first definition that we will need to use is midpoint. A midpoint is a point on a line segment that divides into two equal parts. So if we're given a line segment AC where AB equals BC, then by definition B is our midpoint. The next definition that we're going to go over is what an angle bisector is. An angle bisector is a line that divides an angle in half, meaning that if we have angle ABC and we draw a line that cuts through our angle, that is our angle bisector, then angle ABD equals angle CBD. Another definition that we need to know is what an altitude is. An altitude is a line that extends from one vertex of a triangle perpendicular to the opposite side. So if we look at triangle ABC, our altitude will be the line from A to D, which is perpendicular to line BC. Next, what we're going to go over is the vertical angles theorem. The vertical angles theorem states that the angles opposite each other when two lines cross are always equal. Now, to prove this theorem, let's look at two lines crossing and label the angles A, B, C, and D. You can see that angle A plus angle B equals 180 degrees because when you add these two angles together, they create a line. You can rearrange this equation and say that angle B equals 180 degrees minus angle A. You can do the same thing for angle D plus angle A equals 180 degrees. Both of these angles also create a line. And you can rearrange this equation to say that angle D equals 180 degrees minus angle A. You'll notice that both angle B and angle D equal 180 degrees minus angle A, so we can state that angle B equals angle D. We're going to look back at angle A plus angle B equals 180 degrees and rearrange the equation so that angle A equals 180 degrees minus angle B. We know that angle B plus angle C equals 180 degrees because these angles also create a line. And you can rearrange this equation so that angle C equals 180 degrees minus angle B. And again, you'll notice that angle A and angle C both equal 180 degrees minus angle B. So we can state that angle A equals angle C, proving that vertical angles are equal to each other. We can extend upon this theorem by looking at three lines that cross. We'll label our angles A, B, C, D, E, and F. Now we can see that angle A, angle B, and angle C all make a line. So when you add those angles together, they will equal 180 degrees. You'll rearrange this equation to show that angle A equals 180 degrees minus angle B minus angle C. And angle B plus angle C plus angle D also create a line, so they equal 180 degrees. Rearranging this formula to show that angle D equals 180 degrees minus angle B minus angle C, showing that angle A equals angle D. Angle C plus angle D plus angle E also create a line equaling 180 degrees. Rearranging the formula to show that angle C equals 180 degrees minus angle D minus angle E. Angle D plus angle E plus angle F also equal a line which is 180 degrees. And by rearranging this equation, we see that angle F equals 180 degrees minus angle D minus angle E, showing that angle C equals angle F. We'll do the same thing with angle E plus angle F plus angle A equaling 180 degrees. and seeing that angle E equals 180 degrees minus angle A minus angle F. And lastly, angle F plus angle A plus angle B equals 180 degrees. And we can rearrange it so that angle B equals 180 degrees minus angle A minus angle F. And as a result, showing that angle B equals angle E. Now what we're going to look at is some definitions and theorems on triangles. First, let's look at triangle sum. Let's use triangle A, B, and C. We know that the sum of a triangle's angles is 180 degrees, meaning that angle A plus angle B plus angle C equals 180 degrees. We can rearrange this equation and show that angle A plus angle B equals 180 degrees minus angle C. For the Brahmagupta Theorem, we're going to focus more on right-angled triangles, meaning that angle C will equal 90 degrees. So let's replace our angle C with 90 degrees. We'll find that angle A plus angle B equals 90 degrees. And by rearranging this equation, we'll show that angle A equals 90 degrees minus angle B, and angle B equals 90 degrees minus angle A. Now let's look at what an isosceles triangle is. An isosceles triangle is a triangle that has two sides of equal length. So if we have triangle ABC, side AB will equal side AC. Let's use this fact to prove our theorem 1 of an isosceles triangle, which states if two sides of a triangle are congruent, the angles opposite of them are congruent. So we have that AB equals AC, which is already given. Let's draw a line A to D, and let that be our angle bisector, meaning that angle BAD equals angle CAD. We also know that, of course, AD equals AD. So by side angle side, triangle ABD is congruent to triangle ACD. Thus, angle ABD is equal to angle ACD. Now we can go and prove the converse of this theorem, which is going to be our theorem 2 of an isosceles triangle. Our theorem 2 of an isosceles triangle states if two angles of a triangle are congruent, the sides opposite them are congruent. So we have angle ABD equals angle ACD as our given. We're going to keep our line AD, but this time it's going to be our altitude, meaning that angle ADB equals 90 degrees, which also equals angle ADC. And of course, AD equals AD. So by angle side, we have that triangle ABD is congruent to triangle ACD, proving that side AB equals side AC. Next, what we're going to focus on are circles. The first thing you need to know when working with circles is what an inscribed angle is. An inscribed angle is the angle formed by two chords that share an endpoint in a given circle. So in our circle, we have chord AB and chord BC. The inscribed angle is angle ABC. You also need to note that similarly, an inscribed quadrilateral is any four-sided figure whose vertices all lie on a circle. So with our circle, the inscribed quadrilateral will be quadrilateral ABCD. This next theorem is not a theorem we will use directly, but we'll need in order to prove a theorem we will use for the Brahmagupta Theorem proof. This theorem states that the measure of an inscribed angle in a circle equals half the measure of its intercepted arc. So if we have a circle with an inscribed angle A, B, C, and the intercepted arc being arc AC, it should be pointed out that O is going to be the center of our circle. So we'll draw angle AOC, where O is the center of our circle, and note that angle AOC is equal in degrees as arc AC. Let's draw our line from O to B and focus on triangle AOB. We have that angle ABO equals 180 degrees minus angle AOB minus angle BAO because of our triangle sum. Now because O is the center of our circle, OB and OA are both radii. So OB must equal OA. Recall our Theorem 1 of an isosceles triangle, which stated if two sides of a triangle are equal, then the opposite angles are equal as well. So we know that angle ABO must be equal to angle BAO. So we can replace angle BAO with angle ABO in our equation, saying that angle ABO equals 180 degrees minus angle AOB minus angle ABO. Now by rearranging this equation, we can see that 2 times angle ABO equals 180 degrees minus angle AOB. And rearranging one more time, we see that angle AOB equals 180 degrees minus 2 times angle ABO. Now we want to look at triangle BOC. We have that angle CBO equals 180 degrees minus angle COB minus angle BCO because of triangle sum. We also know that OB is a radius of the circle, but we can also see that OC is a radius as well. Therefore, OB equals OC. Again, by our Theorem 1 of an isosceles triangle, we see that the two sides of our triangle are equal, therefore their opposite angles must be equal as well. So angle CBO must be equal to angle BCO. By replacing angle BCO in our equation with angle CBO, we have that angle CBO equals 180 degrees minus angle COB minus angle CBO. By rearranging this equation, we have 2 times angle CBO equals 180 degrees minus angle COB. And again, by rearranging our equation one more time, we have that angle COB equals 180 degrees minus 2 times angle CBO. And finally, to prove this theorem, we want to solve for angle AOC. Angle AOC equals 360 degrees minus angle AOB minus angle COB. But look, you can see that we've already solved for angle AOB and angle COB. So by taking what we found for angle AOB and angle COB and replacing these angles, we get that angle AOC equals 360 degrees minus 180 degrees minus 2 times angle ABO minus 180 degrees minus 2 times angle CBO. Don't forget your parentheses. By distributing, adding and subtracting, and rearranging our equation, we get that angle AOC equals 2 times angle ABO plus 2 times angle CBO. By dividing both sides by 2, we get that half times angle AOC equals angle ABO plus angle CBO. which equals angle ABC. Thus, angle ABC is equal in degrees as half of arc AC. This next theorem we will use directly when proving the Brahmagupta Theorem. This theorem states that if two inscribed angles of a circle intercept the same arc, or arcs of equal measure, then the inscribed angles have equal measure. Let's look at our circle. We have an inscribed angle, angle A, B, D, and inscribed angle A, C, D. We proved just a second ago that angle ABD is equal in degrees of half of arc AD. And angle ACD is equal in degrees of half of arc AD. And since arc AD equals arc AD, angle ABD must equal angle ACD. Now to discuss the theorem in question, the Brahmagupta Theorem. The Brahmagupta Theorem states that in an inscribed quadrilateral having perpendicular diagonals, the perpendicular from the midpoint of a side to the opposite side passes through the point of intersection of the diagonals. Are you confused? That seems like a very long and confusing theorem, but it's actually really simple. Let's break it down. Let's look at our circle with inscribed quadrilateral A, B, C, D. When line AC is perpendicular to line BD and line EF is perpendicular to line AD, where EF intersects at point G, then line BF is equal to line CF. Now let's prove it. We're given that line AC is perpendicular to line BD and line EF is perpendicular to line AD, where EF intersects at point G. What we need to find is that line BF is equal to line CF. First, let's look at angle FBG, which also equals angle CBD. This angle also equals angle CAD because they share the same arc. Angle CAD plus angle AGE equal 90 degrees by our triangle sum. We'll also find that angle DGE plus angle AGE equal 90 degrees because line AC is perpendicular to line BD, which is given to us. By using these two equations, we find that angle CAD equals angle DGE, and that angle DGE equals angle BGF by vertical angles. Therefore, triangle BFG is isosceles because of our theorem 2 of isosceles triangle. Therefore, BF equals FG. Next, let's look at angle FCG, which equals angle BCA. This also equals angle BDA because they share the same arc. Angle BDA plus angle DGE equal 90 degrees because of the triangle sum. And angle AGE plus angle DGE equals 90 degrees because line AC is perpendicular to line BD, which was given to us. By looking at these two equations, we find that angle BDA equals angle AGE, and angle AGE equals angle FGC by vertical angles. Therefore, we find that triangle CFG is isosceles by our theorem 2 of isosceles triangle. Therefore, line FG is equal to line CF. And by looking at our results, we see that line BF equals line FG and line FG equals line CF. Therefore, line BF equals line CF, proving the Brahmagupta Theorem. This has been Team Cat with Amelia, Rector, and Tran, brought to you by Math 3321 at the University of Texas at Dallas during the spring 2015 semester. I'd like to acknowledge our amazing professor, Dr. Muhammad Akbar, and note the book that we use to help prove this theorem, Geometry for College Students by I. Martin Isaacs. I hope this video helped you to understand the Brahmagupta Theorem better. It seems like a long and difficult theorem to prove, but once you know the basics, it's very simple. Thank you for listening.